Hello everyone. I, Kavya Jain, am pursuing Masters of Construction Engineering and Management from CEPT University. In the second semester of the program, as a studio project for construction project execution, monitoring, and control, I have undertaken the study of a commercial tower. This group activity entailed regular site visits to understand and analyze the live construction project and focused on the execution phase of the project lifecycle. The portfolio briefly demonstrates a few processes undertaken as part of the study, namely project introduction, the analysis of site layout, quality, material, and safety management, green building system adopted in the project, and finally listing the key learnings from the exercise. The project is a world-class office tower located in the state of Gujarat. It is coming up in the GIFT City development. It consists of 18 floors with 2 basements. With a turnkey contract, the cost of the work package being studied is around 142 crores, including preliminaries, cost of construction, consultancy fees, and taxes. A 3D model of the site was developed on Revit. The front and rear views are shown here, indicating the under construction commercial tower and its various entrances. The first exercise is the study of the site layout planning. The site plan indicates the upcoming commercial tower, the 2 basements, and centrally located tower crane. There are 3 entrances for the site. Entrance 1 is the primary entry point. Entrance 2 is for labor entry. And entrance 3 is a temporary gate provided for concreting. The various utilities and facilities like steel yard, guard room, labor toilets, site office, parking are also shown in the layout. A 3D visualization of the GIFT city was prepared in which the project site has been highlighted. Using this model, a material quantities takeoff was prepared to calculate the cost of construction of temporary facilities. This cost is equivalent to 28 lakhs approximately. Risk and waste have been identified on site. 28 risks in 7 categories were listed in the pre-construction and construction phases. A severity matrix was prepared for the same, indicating maximum risks to be in other construction risk category with medium to medium-high severity. 4 types of wastes have been identified on site. First is plastic waste, which includes pipes, bottles, and is disposed of in dustbins. Second is concrete debris and blocks, which is reused in backfilling. Steel waste includes reinforcement and wires recycled by selling as usable scrap. The last is miscellaneous waste such as helmets, jackets, which are sold to recyclers. Quality management is eminent in any construction project. The layout of the quality lab at RMC plant is shown in 2 levels, lower and upper platform level. The lab personnel consists of plant in charge, 2 heads for quality control, and 5 helpers. A list of the equipment at the lab along with the specifications, calibration, make was also studied. The lab consists of compression testing machine, sieve shaker, hot air oven, and other equipment. A curing pond is located close to the lab along with tube casting area. A few suggestions were made for improving the lab layout, which included increasing lab area, more organized equipment, addition of a filing cabinet, and clearance of working platform. The next activity studied is material management. Lead time analysis of 5 construction materials helped understand the minimum time required for materials to be supplied according to approved makes. A layout of the material store was prepared, which comprises of 3 storage racks, filing cabinet, and other construction materials. The materials stored in the first, second, and third racks are also listed. Further, materials at site were classified and provided a codification according to their categories, mainly divided into construction materials, consumables, and semi-finished products. Lean construction involves application of lean tools for waste reduction, improve productivity, and material management. Firstly, the various problems in material management are listed on site, including obstruction of pathway in material store, mixing of different categories of material, and mismatched labels. Lean tools are thereby applied to formulate some solutions for the problems. 5S helps in organizing the workspace. Kanban prevents shortage of material. Just-in-time enables saving in costs of dead inventory. Kaizen encourages continuous improvement on site for systematic storage. Applying these lean tools, solutions suggested are Kanban card for inventory management, material tagging for easy identification, and 5S red tag for visual management. ABC analysis was done for 10 materials identified in the project to categorize them into class A, B, and C on the basis of their quantity, cost, impact, and required controllability. Reinforcement is identified as class A material, while stone, tile, binding wires, AAC blocks fall in class B, and oil, cement, nails, and sand are in class C, and therefore have the least cost and impact out of these 10 materials. In HML analysis, materials are categorized into high, medium, and low class on the basis of the unit price. Shuttering oil is in the high class and requires highest security. Binding wires, reinforcement, and nails are in medium class, while cement, AAC block, and sand are in low class, therefore requiring least security. In safety management, job hazard analysis is studied, which is a technique for identifying hazards on site. 4 types of hazards are identified, namely fall, caught in between, struck by, and electrocution. Here, a fall hazard has been analyzed where a proper working platform is not available for the worker, who is observed to be sitting on dowel bars while chipping the extra concrete from the column surface. 3 types of hazard controls have been suggested for prevention. Firstly, engineering controls, which includes provision of a proper working platform and covering bar ends with rebar caps. Administrative control includes abidance to safety standards and checklists. Lastly, personal protective equipment control suggests usage of a fall arrest system to prevent falling an uncontrollable distance. Green buildings are no longer an exception but have become a norm in the construction industry. The project incorporates several green practices such as provision of green terraces and 75% daylighting in office areas. These practices make it likely to achieve 60 points and doubtful for 15 points on the IGBC Green New Building Rating Scale. With a total score between 60 to 74, the project can easily achieve IGBC Gold rating. The project scores the highest in the following 3 categories. Firstly, usage of 5 IGBC certified materials help it score high in materials and resources category. Wastewater treatment, rainwater harvesting, and efficient landscape practices enable a high score in water conservation category. Proper planning in initial stages of site selection and basic amenities help the project score well in the site selection and planning category. In conclusion, construction project execution, monitoring, and control studio provided us hands-on experience of the various aspects of a construction project with the aid of regular site visits, expert lectures, software sessions, and interactive discussions. The key learnings from the various deliverables is as follows. Site layout planning and analysis helped understand site requirements, components, site visualization, risk and waste identification, and analysis. Quality control is eminent to ensure quality output and abidance to proper standards. The QC lab layout shows the lists of equipment, lab personnel, and areas of improvement for the lab layout. Material management is important for organizing and planning site materials. ABC and HML analysis helps in material classification. Lean tools like 5S, Kanban, Kaizen, JIT help in improving on-site material management. Job hazard analysis identified the various types of hazards prevalent on a construction site. It helped understand the hazard controls required as per OSHA standards to avoid or mitigate the occurrence of a hazard. In the Green Building Rating System, the project is likely to attain IGBC Gold rating. The highest scores are in the site selection and planning, water conservation, and material and resources categories. Thank you.